Okay, so here is an introduction to our robot's parameters, how to use global parameters, how to use local parameters, um, what are, we have specific parameters for this design that is being created in Fusion 360. I'm going to show you how to add a new part and add global and local variables to it. I'm going to use these two words pretty interchangeably. Parameters equals variables. Very similar to how you have variables in coding. I'm going to explain what configurations are. I'm going to explain how to make assemblies. They're essentially just the same as part files, but you can add other parts inside them. And then I'm going to explain, it's really important, there's a certain way to save and update changes that you make. So let's start with global parameters. Here's the Fusion 360 as you open it. If you don't see this, you should be able to go to this drop down and click on the Team Hub. Now, global parameters. This is the global file. It's like a part file, but there's nothing inside it. All that is inside it is parameters. These guys. Let me show you what these are first. I'm going to go to our electronics division folder and our Robto assembly. What are these global parameters? I've chosen them as variables that we might need in almost every single part that we create, or many of the parts that we create. This guy right here, I'm going to measure it. You can see it is 292 millimeters. If we go into our, and I'll explain what this all is, what you're looking at first. If you front to back total, that is a global parameter, and you can see it's set as 292 millimeters, which matches this guy. If I go into my global parameters and I change it to 392 and then save, you can see the down bottom left, it's updating everything. And now I go to my Robto assembly. Nothing's changed. I have to go up to here to press update. I'm showing you this to show you what the power of this global parameter and what this specific parameter, the front to back length, represents. I'll just let it load here. Check that out. With one click, or a few clicks, we changed the entire dimension of the robot. Say at some point we need to shorten it, make it a little longer. There are various other things that we might want to change. It'll be that easy. So what do our other parameters represent? Here's the favorite ones. Basically, let me go here. Favorites equals global. Electronics box height. What does that one represent? That represents the height of this guy right here. Front to back total, as I showed, is that guy. Fitment tolerance. I'll skip that. Interior width. That is the width of this inside right here. And then duck box front to back is from here to there. That distance. And then back to fitment tolerance. Basically, we're going to have various areas where we might want there to be some space, right? So fitment tolerance is going to be a global variable that we can use in many places to create a very tight fit, but where they'll still slide, where they'll fit inside. And I'll explain how to use that later. So these are global parameters. Okay, I've switched it up a little bit. I'm going to explain this. I'm not sure at what point. Next, I'm going to show you how to create a new part and add a global and local variable to it. So let's go. New design. And what I'm going to be designing is a tray that goes inside of here. So new design, sketch, user ground here. And now rectangle. It's going to be an arbitrary rectangle. Now to use my global parameters, normally I could type in like front to back, but nothing is showing up. It's not showing up because we need to add our global parameters into this file. How do we do that? We go to insert, insert derive. This pulls links and design features from another design into the active design. It's going to ask us to save this part. We're going to call it the table tray, and it's in the correct folder. And now it's asking us what, based on our insert, I'll show it again what's happening. Insert derive. It's asking us, what do we want to reference? I want to reference this guy. You can see one of these table trays is the one we just created, and one of them is, this one's the one we just created. This one's the one, a previous one that, well, I tried to delete. Now it's asking us configuration. I'll explain configurations later. We'll hit OK. It's asking us now, we're actually looking at the global parameters file. There are no objects here because we don't want objects from the global parameters file. We actually want our global parameters, aka favorites. So I open the checkbox, I hit favorites, OK. That's it. We just added the global parameters to this file, and we're back in the file now. How do I access them? Well, we're going to edit our sketch. It's as easy as, let's see. Oh, it's not going to work. This is very curious. Oh, I see what's wrong. This is great to show you guys. I still can't access them. Why can't I access them? I need to go into my configurations. There's only one configuration right now. I'm going to click on my Add Parameters button. It shows me this menu. And you see various things here. What you need after you've added from insert, you need to go to global configuration derived, user parameters, and here they are. Here's our global parameters. To actually add them into our file, we need to hit star on every single one of them. That brings them over to our file. Now OK. Now we can do it. Edit sketch. See how they show up now? Enter, enter, ta-da. I'm going to edit this guy. Interior width. Enter. Wonderful. How do you add a local parameter? The best way to do it, we're in our configuration 1. This plus button right here. Add a user parameter. User here means local. Now I'm going to say tray height, and it's important to note that this is local. So I'm going to put local on there. Let's say this is 5 millimeters. Okay. Now I'm going to put the check mark on. The check mark is going to help us later by adding it into this configuration. Once you see what configurations are, you'll see why adding it here is important. So let's extrude this. And instead of typing in 5 millimeters, I'm going to type in height, tray height local, and it just updated that. So let's see, we can actually go in here. Let's say this is 50 millimeters, enter, and it just updated. That's the basis of a lot of what we're doing. Enter. So that's how to add local and global parameters to a file. Now I'm going to explain configurations. I'm going to go over to this extrusion file. This is a very basic part. It's going to be used in a lot of other parts. The only variables it's referencing is going to be global and its own local variables. And it actually needs local variables to be used in a different way than we used in table tray. It's the same way, but now we introduce configurations. What is the idea of configurations? You can see that once I extrude this part, let's make it more substantial. We get some aluminum extrusion. We are going to want multiple sizes of this throughout the robot. And what Fusion 360 allows us to do is within this single extrusion file to have multiple versions of this. And the multiple versions are multiple configurations. You can have this version of this part be different in multiple directions. You can increase the width, the height, all of that. And all of those updates will be tied to one version of that file, which can be referenced and used in other assemblies. I'm going to go in here and we don't need this. Okay, so let's actually, right now we're not actually using this variable. We need to use it. Let's go inside to our extrusion, edit, edit feature. I don't want it to be 84, I want it to reference length. Extrusion length local. And as you can see, it's updated to be 1 millimeter as the configuration tab says. We don't actually want it to be 1 millimeter. This is interior horizontal. What this represents, if I can show you, we're going to have our electronics box, and we're going to have an extrusion going along the bottom and along the top. So that's what this part is going to be. So how wide does it need to be? Here's a formula, and I'll explain the formula. This is the interior width, and as you can see, it's / reference. That means we are grabbing it from global variables. It's the interior width of the robot. What are we doing here? We're subtracting a certain amount. We are subtracting the tolerance on each side. We're multiplying it by 2 to get each side. I'll copy this over and plug it into here. And now we get this part. And then we need some extrusion to fit in between them. So let's create that. I'm going to create that. We're going to add a configuration. We're going to name it electronics box vertical So what's this formula? It's the electronics box height, / reference means it's global. We're going to subtract the width of the two extrusions because it needs to fit in between them. And we're going to subtract tolerance. Let's paste that in. Check this out. We have both of them, like both of them exist. Let's add our third. So tray. You can double click it to rename it. So we're done with our configurations. How do we use them now? I'm going to go into this. This is going to be a assembly that represents the interior of the electronics box. So I have this sketch that I'm making. This is very similar to that part that we created earlier, the table tray. You can see we have our interior width. It's best practice to create a sketch that represents the perfect part. If we had a perfect world, everything fits. And then add borders for our tolerance. So that's what I'm going to do. I'm going to add a line up here. And then got to make sure to, because this line could be at any arbitrary height. So tolerance. And as you can see, this electronics box assembly part has already been supplied with the global variables. Perfect. Now, what this line that we've created, the smaller rectangle, allows us to do, it allows us to put the other parts inside of this inner rectangle. What we're actually going to have to do is save this part. We can only use it in the electronics box assembly. We can only use this simple part inside of other more complicated parts after we've saved it. This is getting into that hierarchy idea. Let's go into our assembly, finish sketch. I need to see that. This represents our electronics box. So now we can start putting pieces inside it. You can literally just drag. Another way to do it is to insert into current drawing, or you could insert component. Let's select our extrusion. Now, this is where it gets pretty interesting. We can select which one. Let's start with our interior horizontal. It loads. So the best practice for this is to do a rotate. And then if you've designed the other stuff like in a good way, now you can do a point to point. So I'm going to pick the corner of this. And I'm going to pick the inside tolerance area that we've created. If we've done our math right, it fits perfectly. Okay. Now, you never want to create a copy when you're adding in these components. Move copy. Like, if I try to go here, move copy, and like, it's never good practice, even if it lets you to create copies. You always want to drag in another component. It can be difficult to move them after you put them in. I'll show you how. So you want to get it right the first time. So I'm going to take a point here and move it here. Same thing with these guys. Now we're using our other vertical. I'm going to rotate it. Now our point to point. Okay, is it going to work? Yes. And lines up perfectly. It can be really finicky to get it to line up. You have to make sure your math is on point. And it's actually helpful. Like if it doesn't line up, it points out where you made a mistake. 90 degrees. Point to point. And right here. Wonderful. Now let's do our last part. The tray front to back. I want it to go right about here. You gotta have, it looks good, but you gotta have a little bit of attention to detail. It's actually not lined up here, so I'm gonna do my point to point again. This should work. And there we go. Perfect. Now I'm going to hide the sketches. Actually, I don't need to hide them yet. I'm going to save because the fact that I have this interior and exterior is going to be important for my next step. It is very important for me to save it after I've completed it so that the next part that I go to will like be able to pull from a fully updated part. I'm going to drag in my electronics box assembly. There's only one configuration. Gotta wait a little bit because we just saved it. SolidWorks has the same thing. It's a lot faster. I think the reason that SolidWorks is faster is because it's updating just to your local computer, while Fusion 360 here is updating all of your changes to the cloud so that the other team members can see them as well. So here's why the point, keeping that sketch visible is important. I'm going to do a point to point, and I'm going to pick the exterior here and line it up with that guy. Okay. And it fits perfectly. You can even, this is kind of cool, named views, no, analysis. You can set it up to where it'll cut inside. And you can see there's tolerance. Fit. Wonderful. So I've covered how to make assemblies. Now I need to explain how to save and update. And this is tied with the hierarchy. This is really important. If you don't do this right, it's going to take you a lot longer to, you're going to be waiting for the designs to load for a long time. So how do you make changes and how do you save them and update them? If you make a change at as low of a level as this extrusion, you need to hit save. Let me restart saying it another way. The hierarchy starts with global parameters and it trickles down to the more and more complex assemblies. Simple, more complex, and more complex. This part down here at this point is referencing this, which is referencing this, which is referencing this. And so when you make a change down here, it trickles down and you have to update all of these in a certain way. So what you're going to do is you save, and then I can actually show you what happens. So we're at this level and we're going to make a change to it. We are going to hide the sketch, and now we're going to save. So it's important, very important, that after you're done making changes on a certain level, hit save. And then what you have to do after that is you have to then go to the assemblies that are above it, and you'll see this icon right here, chain and a hazard. And what it says is update one child component to latest version if it is available. It is noticed that something needs to be updated and it's waiting for you to press the button to update it. So I'm going to hit that, getting latest updates here down in lower left. Notice that this area currently has a sketch, and what I'm predicting is going to happen is, bam, the sketch disappears because it pulled in the most recent updates. Now this is the last step that's very important. You have to hit save here. Now it's uploading that to the cloud. So if you make a change all the way down here to the extrusion, you have to hit save. You have to go to the next part that it is referencing it. You have to hit the little update button. Then you have to hit save. Then you have to go to your final part. You have to hit update and then save. If you do that, it'll reduce a lot of potential headaches. So I'll conclude with showing off a little bit of what the local parameters can do. Since we want a limited amount of global parameters because of all of the update complexity that you just saw, you want as little parameters to be global. You can add as many local parameters as you want. As you can see here, for this Robto assembly, there's a lot. As you can see, I've marked all of them so that I can actually change them inside of this configuration one. I'm actually going to rename this Robto configuration. To see what I'm about to do more to help explain it, you can see inside of here, this is the front to back profile. Here's our electronics box. Here's our table. The table is set to a local variable called table height. I probably could have changed the variable to be table height local to be a little more clear. And as you can see, it defines this height right here. You can also see all my walls are set to wall thickness, which is another local variable. So let's see what happens when we change those. Let's do wall thickness to something just crazy. Oh, it's at the end here. So let's make this something crazy, like 15. Enter. Bam. We just made, like, instead of going in and changing everything, you can make a big change like that in seconds. Let's say our sprocket height, we need it to be a little higher. I'm going to make it 130. Ta-da. Undo. Another one where I was showing inside the table height. That's this guy. Change that to 25. That's probably a little more realistic. So this allows us to make really fast changes. Thank you for watching. Hope you learned Hope that was clear. Let me know if there are any questions.